Hello, welcome to Statistics Bio 7. Now we are the discussion for the topic interpretation of DCA ordination in biostatistics. How to analyze the DCA ordination in biostatistics for RStudio. That video already published in our channel. That video link mentioned to this video description box. The continue part of the DCA ordination in interpretation. In ecological studies, ordination techniques are pivotal in understanding the distributions and diversity of species across environmental gradients. Among this technique, Detrended Correspondence Analysis is especially useful in community ecology due to its ability to remove arch effect and standardize gradient lengths. The study aimed to use DCA to explore how species composition vary across five distance habits: decide, forest, grassland, mountain and wetland. Those ordinations we attempt to visualize and interpret understanding patterns in species distributions, revealing how species group according to the environmental variation. The table for the eigenvalues and access strength. First that access DCA1 and DCA2, the totally 80% of eigenvalue present in the DCA1 and 2. The value of the eigenvalues for DCA1 0.41. The eigenvalue percentage for the variation explained 65. And the next one for the largest the eigenvalues in table DCA2 0.1000 15.7%. So the what are the eigenvalues in the DCA? In Detrended Correspondence Analysis, DCA eigenvalues represent the amount of variations explained by each ordination axis. Higher eigenvalue indicate the strong ecological gradient captured by that axis. So the interpretation of the table, the DCA axis 1 has a eigenvalue of 0.4142, which account for approximately 65% of the total variation in the species composition across habits. This means that the primary gradient separating the species like due to a major environmental variable such as moisture, evaluation or habit type is effectively captured along this axis. The long stretch of the species and the side scores along the DCA1 confirm its dominant role in structuring the dataset. So the DCA axis 2 explain the 15.7% of the variations within eigenvalue of 0.100. This axis capture a secondary gradient which must represent the factors such as mirror evaluations difference, distribution history or micro habit variability. The DCA axis 3 and axis 4 have a low eigenvalues for 0.0563 and 0.0265 respectively, explaining only the small populations 8.8% and 4.2% of the total variations. This axis may account for the subtle ecological variation or noise. Including them in interpretations is usually necessary unless detailed multivariate relationship are being explored. The cumulative variations explained. The cumulative variations by the first two axes is approximately 80.7%, indicating that the 2D plot using DCA1 and DCA2 is a wild and reliable summary of the species habit relationship in the dataset. This high cumulative percentage supported the ecological robustness of the ordinations and validated the visual clustering scenes in the DCA plot. So the ecological implications, the dominance of the DCA1 suggests a strong environmental gradient like habit type or resource availability. The comparatively lower value of the DCA2 to DCA4 implies that while there are additional patterns, they are not as ecological important or widespread. This confirms that the DCA axis 1 is primary drives of the species turnover, making it the most important axis for the interpreting habit difference. So the figure of the interpretation of the DCA plot. The grassland site S4 to S6 cluster toward the lower left quadrant, indicating a distant species composition separated from others. The wetland site S7 to S9 lead to the far left and slightly upwards, forming a well separated group. The forest site S1 to S3 a group that the far right along DCA1, showing the strong habit drives divergence, and decide group for the S10 to S12 and mountain side to S13 to S15 overlap slightly near the center top, suggesting potential ecological similarity to traditional species presence. The gradient along DC1 clearly separates the forest right and the grassland to the left, implying that they represent the moisture or evaluations. So the different habit mentioned to the different color for the each one habit, the desired forest, grassland, mountain and wetland. So the conclusion of the DCA ordination. The Detrended Correspondence Analysis DCA effectively revealed the ecological patterns in species distribution across the 5 distinct habits: forest, grassland, wetland, mountain and desert. The first two DCA explained access 80% of the total variations, indicating the strong environmental gradients influencing the species composition. The forest and grassland side show clear separations, while wetland formed a distance clustering with specialized species. The overlap between mountain and desert side suggesting the traditional ecological zones. Overall, the DCA provided to be a powerful tool in visualizing habit-based species variation and supporting the ecological interpretations in biostatistics. If you have any doubt on this interpretation of DCA ordination in biostatistics for the 5 different habits, leave me comments in the comment box. I will explain to you. And if you like this video, click to the subscription button, support to me, join to our channel membership or the donation page link mentioned in this video description box and comment box. Thank you for watching this video.